Hello all, this video is on the new 7-in-1 soil integrated sensor which gives, apart from the NPK values, it gives soil pH, temperature, moisture and electrical conductivity. It has got 5 arms, that is steel needles, 5 steel needles, and it has got a IP68 grade casing, so even if you dip it in water it is safe. The power required is 12 volt, 1 ampere or 2 ampere, and the data signal is RS485. It has got 4 wires, the brown and the black wires for power source, and the blue and yellow wire for RS485. Blue is B and yellow is A of RS485. We'll be using this RS485 to USB dongle to analyze the register values, and power is connected to 12 volt, and we'll be also using RS485 detail, which is auto direction mode. So no, it is not necessary to enable the direction, it is auto direction, and we'll be using ESP32 microcontroller, and finally we'll display the values on a 20x4 I2C enabled LCD. I2C backpack is soldered on this LCD. So let us use the RS485 to USB dongle to analyze the data first. Connect the yellow and blue wires to RS485 and plug in the NPK soils into the soil. And DC supply used is 12 volt 2 ampere. It requires minimum 12 volt 1 ampere. Plug in the USB dongle, RS485 to USB dongle to PC. It will be allotted a COM port, and we'll be using this COM port to analyze the data. Now let us use the RS485 sensor configuration tool. This tool is actually for a 3-leg NPK sensor, but it can be used to analyze the 5-leg also, but it gives only the NPK values. Select the soil, phosphorus and potassium in one value. Select the COM port, baud rate is 9600 and device address is 1, connect. Now you will get the values: N nitrogen, P phosphorus and K potassium values. All 3 values in mg per kg are displayed at the bottom, and to the right hand side bottom you can see the send data. It is a hex data. This is very important hex data. We'll analyze this hex data and we'll be using it in the code. Now let us disconnect the USB dongle and check the send query data and the received query data. Copy the send query data. First data is for nitrogen. Copy that and paste it in the notepad, and also the received data also copy and paste it in a notepad. Now let us analyze this hex data, and the 4th and 5th byte of the received data has got the actual value in hex. We can feed it in the calculator and convert the hex to decimal value, and finally we get the decimal value. Same way for P, that is the phosphorus. Let us copy the send hex data. This is the query data, and paste it in the notepad, and the received data also let us paste it on the notepad. That is the 4th and 5th bytes have the actual value. This value is in hex. Here it is 003C. That is the 4th and 5th byte, 003C. If we feed it in the calculator and convert to decimal, it will be decimal 60. Same way for the potassium. There is the send query data, and copy the received data from the tool, 485 sensor configuration tool, and paste it in the notepad. The 4th and 5th byte or the actual data, and convert to decimal to get the decimal values. So this gives only the NPK values, as this tool is designed for only 3-leg sensors. After sending the query, we get the received data in hex, and the 4th and 5th bytes contain the actual value. We can convert this hex value to decimal and note it down. So this is how to send the query and get the data and parse out the data. Now instead of sending NPK, instead of sending 3 hex bytes arrays, we will be sending a single array, as the address for NPK values are contiguous as per the data sheet. And also we'll be using the hex code to get moisture, pH, temperature and electrical conductivity. Now let us use CoolTerm software to analyze the register data. Open the CoolTerm software, set the options, and then under connection send string you have to paste the hex code, that is the query data. Copy including the CRC code, last 2 bytes are error code. Copy it in and paste it under the send string after selecting hex. Now click on send, you get the data back. That is it reads the register data starting from address 1E, total 3 registers it is reading, that is the NPK values. We are sending data 01, 03, 001E and then 0003. That is a total 3 number of registers we read, and finally we get the value as 0103. 0006 is the total number of bytes following. 4th and 5th byte for N value, 6th and 7th byte for P value, and 8th and 9th byte for K value, potassium value. These values can be converted from hex to decimal. So this is how we are going to do the conversion in the Arduino code. If you understand this hex query data and the receive query data and how to parse it, it is easy to code in the Arduino. So here, instead of sending NPK 3 separate arrays, we are sending a single array to get the to read the data from 001 starting address. Same way for pH value, we send 01, 03, 00, 06. 06 is the address, and then 0001, that is 1 byte of data, and paste it under the send string to get the value. Paste the received data into the notepad. Here the 4th and 5th byte has the actual pH value. This is in hex value. Converted it to decimal, we get 660. As per the data sheet, this pH value should be divided by 100 to get the exact pH value. It is 0.01 pH as per the data sheet. So you have to divide it by 100. This is the pH value. For soil moisture and temperature, you have to divide it by 10. For soil moisture, this is the hex code, that is a query code to send. As per the data sheet, 0006 is for pH value, that is a register address for pH value, and 0012 is for soil moisture. So accordingly, we will send the hex code, query code, using the send string of CoolTerm. After selecting hex, paste the query code and then click on send. You get the data back. Copy that data and paste it into notepad. Here the 4th and 5th values are the actual value for the soil moisture. Convert it to decimal, we have to divide it by 10. The soil moisture and temperature divide by 10. Soil pH we have to divide by 100 as per the data sheet. So soil moisture divided by 10, you get 15.5, which is the soil moisture. So soil moisture is 0 for dry soil, and the total water means it will be 100%. And the soil temperature, paste the query data and get the data, return data. The 4th and 5th byte, you convert it to decimal and then divide by 10. It is 32.7 is the soil temperature. Finally, for soil conductivity, paste the query code and get back the result. The final 4th and 5th byte is the electrical conductivity. It is in microsecond per centimeter, no division here. So this is how to analyze using the query send data. That is, the hex array is sent, and finally we get back the data and parse out the actual hex values. And let us use the QMod master to analyze the register, that is RS485 Modbus registers. The QMod master is open source software, no installation is required. Go to options and then select Modbus RTU, and then here you have to feed in the COM port allotted to the RS485 to USB. Here it is COM3 and the baud rate is 9600. Again, go to options, settings, and most important is you have to set the base address to 0 and the Indian is big Indian. This is the settings, and Modbus mode is RTU and slave address is 1. That is the address of the NPK sensor. And the function code is you have to select read holding registers, which is 0x03. That is what we use in the hex code. Now click on connect and number of registers select as 1. And the most important is the address of the registers. 001E, as per the data sheet, 001E is the address of the nitrogen. So for feed in 1E and after selecting hex, number of registers is 1, and go to command and then click on read write. Every time you have to click on read write. Change the format to decimal. You get directly the decimal value. Next address is 001F, which is for phosphorus. Change the start address to 1F, which is 001F. Number of registers 1. Command read write. You get the value in decimal. And third is the potassium, 0020. You get the potassium value. And there is also the address 0100, which is the slave address. That is the address of the NPK sensor. Now let us see after feeding 0100 and reading that register. Click on command read write. It gives the value 1, which means the slave address is 1 of that NPK value. You can also write the holding registers to change this value. And the baud rate you have to feed in 0101. You get 2, which is 9600. So 0 means 2400, 1 means 4800, and 2 means 9600 baud. The slave address and baud rate you can change using the write holding registers. Now let us change the number of registers to read to 3 and then start address to 1E, so that the contiguous address 1E, 1F20, the NPK values as per the data sheet are contiguous. So as the registers are contiguous, you can use the starting address as 001E and then provide the values for to read the 3 registers. You get all the 3 values. Now let us feed in the address 0006 to get the pH value. So it is 667. This has to be divided by 100 finally to get the exact pH value. And the address of the soil moisture, to get the soil moisture value is 0012 as per the data sheet. So feed in the address as 0012, number of registers 1, click on command read write, you get the soil moisture. This has to be divided by 10 to get the final value. And 0013 is to get the temperature value. 0013, click on read write, you get the temperature value. This also has to be divided by 10 to get the exact value. And finally the conductivity conductivity address is 0015. Feed in the address 0015 and number of registers is 1. You get the read write, you get the electrical conductivity in microsecond per centimeter. So all these values we have analyzed. Now let us see the CRC error code. Go to the online website, link is given in the description below. Select input as X and output as X, and CRC 16 Modbus is the value we have to get, that is the CRC error code. Now feed in the query sent, except the last 2 bytes, send the query byte. Copy the query byte, that is 0103, 001E is the starting address, 0001 is the number of registers. This is for nitrogen. Copy this hex code, paste it into the website, that is to generate the CRC 16 error code. This is very important. If you change this CRC error code, you will not get the value. You get a value here. So the low byte should be written first and the high byte to be written in the last. So it will be in the reverse. Finally it is E40C. So this is how to get the error code. It is given in the data sheet, but this is how they calculate the CRC error code. Same way for P value, that is a phosphorus value, and also the potassium value. Paste the query code without the last 2 bytes and then generate CR16 Modbus error code and note it down. The same way, let us find the values for the contiguous. There is a NPK, all 3 values 0103, 001 is the starting address, 0003, that is the number of registers is 3, and copy this hex, paste it into the website and click on generate CRC16 Modbus. You get the value. So write it in reverse, that is 65CD. This is the error code. So this is the hex code we send in our Arduino code to get back the values, that is the NPK values. Same way for pH value, copy and paste without the last 2 bytes, paste it into the website, you get the error code, CRC16 error code. And for soil moisture, soil temperature, and then soil conductivity, all this you generate the error code and note it down in the notepad. This will be used in our Arduino code to send the query. That is, we send query the hex data and we get back the data. In the received data, the 4th and 5th bytes have the exact value. We convert it to decimal and finally display it on the LCD or the serial monitor. So this is how it works. If you understand this hex code, it is easy to understand the code. Now let us use the ESP32 microcontroller with the NPK sensor. In between we require is RS485 to TTL auto direction board. Here we use the ESP32 GPU 17TX2 that is connected to TXD of RS485 to TTL. GPU 16 RX2 is connected to RXD of RS485 to TTL. It is direct connection, and A and B is connected to yellow and blue wires of RS, that is a NPK sensor. The connection is simple, but it is straight in between the ESP32 and the RS485 TTL. The 3.3 volt required for the RS485 to TTL is taken from pin 1 of ESP32. Ground pin is 38, pin 38. This is the code. Here we declare the serial port, serial 2 of ESP32 used, which is GPU 17 and 16, and then we send the query data. That is the query data. First query data is to get the all 3 NPK values, as we have calculated and noted down in the notepad. We are using this hex code, which is for getting NPK value. 01 is the address, 03 is the function code, read register, and 001E is the start address, and 0003 is the number of registers. Final 65CD is the error code. This is very important. If error code is wrong, you will not get the data back. And finally, we'll analyze the received data and parse out later in the code. The second hex code is to get the pH value. Here note down the address of the pH value, or pH register is 0006. So 0103 is the function code, 0006 is the address, 0001 is the number of registers, 1 register, and then 640B is the error code. There is a CRC16 error code. And the next is for soil moisture. Here we use the address, register address is 0012, which is the soil moisture address, and then the relevant error code. And for soil temperature, the register is 0013, and for soil conductivity it is 0015. So the register address and the error code, CRC error code, both are very important. So finally we have 5 hex codes. First is for NPK and the other values, the other hex code, and we begin the serial port 2, and in void loop we call different functions to get the values. There is totally 5 functions. First function is to get the NPK values. The other functions to get the soil pH, moisture, temperature, and conductivity. In the first function, that is the print NPK values, we send the hex code using serial.write. That is this is the hex array code we have created, and we send the hex code using serial.write and wait. After a delay, we read all the serial data we get back from the NPK sensor. That is total 11 bytes we get for this NPK value. As we have that contiguous address we are using, we get the 11 bytes, and then we parse out the data for that is 4th and 5th byte N, 6th and 7th byte P, and 8th and 9th byte for potassium. So all three values we separate and print. And the next is for the soil pH. We send the same way we send the hex code, and we wait and read all the data. Here it is 7 bytes of data. As number of registers 1, we get only the 7 bytes, and we read out the 4th and 5th byte, and we divide this pH value, we convert it to decimal and divide it by 100. So this is how we get the pH value. For pH, as per the data register, as per the data sheet, we have to divide by 100. And for soil moisture, we send the hex byte, we get back the value, parse out the 4th and 5th byte, convert to decimal. Here we have to divide by 10. For soil moisture and the soil temperature, we have to divide by 10. So this is how we get the soil moisture and temperature in decimal value. For pH we divide by 100, for the other two we divide by 10. For soil conductivity there is no division, we just parse out the 4th and 5th byte, and this directly converted to decimal, and this is the conductivity, electrical conductivity in microsecond per centimeter. So we have got all the values: NPK value, pH, soil moisture, temperature, and conductivity. Upload the code to ESP32. Once the code is uploaded, open the serial monitor. Now you get the values in decimal. That is the NPK values, and then the soil pH, that is divided by 100 value, soil moisture and temperature divided by 10 value, and then the soil conductivity. All values are displayed. Now let us add a 20x4 display to our circuit. So this is the 20x4 LCD, and we have added an I2C backpack to this to reduce the number of wires. So we have to use only the SDA and the SCL pins. SDA and SCL pins of ESP32 connected to SDA, that is GPIO21 is SDA, GPIO22 is SCL. It's connected direct, and then the RS485 TTL connections are same. We get the power supply from V in pin 19, that is 5 volt for the LCD. And this is a code modification. We include wire.h and liquid crystal I2C library, and the query data is sent. And very important is 0x27, which is the I2C LCD address of the 20x4 LCD. This is very important. If this address changes, you will not get the value. And in void loop, we call the different functions to pass out the data of NPK, pH, moisture, temperature, and conductivity. And we print in the serial monitor as well as on the LCD, in the I2C LCD. So upload the code, we get the values in the serial monitor one by one, that is NPK values and all other values, and in the display also we get neatly the values: N value, P value, K value, and other values. Now let us pull out the NPK sensor from the soil and see whether it is changing. So it is, the values are changing in real time. Plug it back, you get the normalized value. Within 5 seconds it will normalize, the values will be normalized. Thank you for watching.